it's Fran again in the lab, still here in the lab, haven't quite moved everything out yet, and I got a repair that came in. This is one of my original The Sweet prototypes that I made back in 2000, late 2000. Those of you who might know some of my back catalog of videos might have seen some years back I did a video about my Lou Reed story, in which I talk about hanging out with Lou Reed for a day at his studio, and on that day I brought along one of these prototypes that I had built back in 2000, and there were, I think, 6 original ones that I did. I built these in my apartment back in Greenpoint, Brooklyn, back in summer 2000. As I recall, I spray painted the cases because this was like on the front stoop like of the apartment building, and assembled them on a little table that I had in the apartment. But it was all done right there, and I thought it would be interesting to take a look in here to look at some of my old and prototyping techniques, and most of which, well, let's face it, all of which I still use today. So take a closer look at the Sweet prototype. All right, this is it. I already took the back plate off. The customer had done some modifications, put in some of this rubber material, I guess, to insulate it. But I had written in here to the customer, Bob Halligan, to Bob and Joy, Fran Blanche, 11/3/2000. So I guess I sold this in November 2000. Yeah, but the customer, Bob Halligan, he had written in the blue here, and that's actually engraved. So I guess he really wanted that to be permanent in the effect. It looks like part of a rubber intertube added for insulation. When I got this, the label is delaminated, which I think from photos that he sent me before shipping it appears that this happened in shipping. The package must have gotten wet or been stored in a wet room, and yeah, that paper label delaminated. Now, when I make production pedals, all my production pedals are silkscreened in enamel, but I still do this from time to time. If I'm doing just a one-off prototype, I'll make a paper label and glue it down to a painted case, and that's what I did here. This would have been inkjet printed on photo paper, and to give it the glossy sheen, I guess once it would have been printed, I would have waterproofed it by spraying it with acrylic, which is why it's nice and shiny. And spraying it over with acrylic would seal it, make it waterproof, so if it got, you know, a little bit damp, that the ink wouldn't run. And even though this obviously got damp, the ink didn't run. And then what I would have done to tack this down is sprayed it with some contact adhesive on the back side, and then glued it down to a painted case. You see this is rough here because again, I painted these on my front stoop in Brooklyn, so these cases were not sanded or prepped, or there's no undercoat, there's no primer or anything, so you can see the casting through the paint. When I did production on these pedals, I did a lot of surface preparation and such. It was very different. But I'm going to reattach this label, put some glue in, using the same technique that you use for repairing veneer that's delaminated, which is you take a little tool, like a little spatula type tool, put some, dip it in glue and kind of put it underneath to sort of make like a little, wipe the glue on the bottom side of the label, and then press some flat weights on the perimeter, glue it down and let it sit overnight, and that should reattach all around. But this sort of label thing is what I did for prototypes. And if I was doing short runs, like if I was doing like a custom pedal for someone, that I'd make just 1 or maybe 2 of them for them, I would usually do a paper label, unless they really wanted to pay a lot to get a silkscreen made, in which case I would do that. I've done it both ways in the past. But this is pretty common for prototyping, paper label. And inside, again, this is my prototype. Again, the customer, he added some of these rubber parts in here. It's like this pad here and these blue pads underneath the jacks. It looks like the kind of material used for repairing inner tubes, like bike repair inner tubes, because those things are sometimes have sticky stuff on one side, but it looks like that's what that is. But I didn't put that in there originally. That's been added since. But yeah, so it's a perf board, solder perf board. Looks like I've used number 6 screws with a number 6 tapped standoffs here, these aluminum standoffs, which I have glued down to the inside of the case there. And that's a technique I've used for a long time. In fact, I use it just recently. If you watch that video I did about the handheld voice recorder, even though I 3D printed that, I used a very similar technique where I 3D printed the standoffs, and then after, because I was making a handmade circuit board, after I made the circuit board, I screwed the standoffs to the board, all 4 of them, and then superglued them down to the 3D printed enclosure, same way I did here. But I think, I'm trying to think of the glue, because this is 2000, that's probably goop. The goop glue, they made us, I don't even know if they make it anymore, but they used to make something called shoe goop, and it was a form of goop glue that would harden to basically, it wouldn't really reduce down, it would stay, it would maintain its volume, and it would turn into a clear, elastic, rubber type stuff, kind of like with silicone, but I don't know if there was silicone in it, but it was not silicone based as far as I know, but maybe it was, who knows. But it was sort of a jelly type, it stunk like crazy, but it was like a jelly type glue, and I would use shoe goop back in those days to sort of my universal glue. That's probably what that is, because it used to work really well on metal parts. But I would have done this the same way that I did that other project, where I would have built the circuit board, and then before I wired it up, I would have attached the 4 standoffs with the 4 screws to the board, and then before there's anything in the case, I would have put 4 dots of glue on those standoffs, and I'd even see how I cut a little cutaway here for a battery, so I would have dropped a battery in there, you know, and just for clearance, and then I would have put the glue on those 4 standoffs and then dropped the board in and glued it to the case and let it sit overnight, and then the next day I would have removed the battery and then unscrewed the 4 screws, taken the board out, and then the standoffs would have been stuck there in the right place, and then I would have wired it up, and yeah, but that's how I would have done that. I also noticed I used some goop on the main condenser there. It's a horrendously large capacitor, but again, this is a prototype. I was using the parts I had on hand. In that value, that was the voltage I had, so it just barely fits, so I just glued it in. Yep, so lots of electrolytics, and I was worried that this would have to be recapped. I used high quality caps back in the day, but you know, they do dry out, and in pedals like this, if there's a failure in the effect, it's almost always because there's a cap has gotten dodgy. But I was hoping I wouldn't have to replace any of these, because this is like a proto breadboard and it'd be very messy. I did notice that the switch isn't snapping, and just buzzing this out with a multimeter, I did find that the switch is actually stuck. So, but I wanted to test the actual circuit, so I'm going to turn on my signal generator in here, and get my scope on. And this is handy too if you work with pedals or anything. It's very simple. It's just a jack with you know, 2 bare wires attached to it. It makes it easy to attach a scope to the output of the pedal, so you don't really have to mess around too much with it. It's real easy. You don't have to worry about tacking onto the case for the ground, because the ground connection comes right here, and you just put the scope probe right there. So now it's grounded. whenever I get a pedal in to test, the first thing I want to do is make sure there are no shorts or shorts in the components in the circuit. So before I even power it up, I take a multimeter and I just switch it to the ohms function and just take the resistance from rail to rail. So from ground to the positive, and take the resistance on there and make sure that it's not a low value. Yeah, okay, 1.5K, and that's the main condenser charging. But that's what you want to see. You want to see the value going up and up. That's the caps charge. If it were 100 ohms or 60 ohms, then yeah, you'd have a shorted component in there, and you won't want to fire it up if there's any low resistance, because it's just you got a short or near short, and you don't want to apply the power, because you're just going to cook whatever, unless you want to really find that part really fast and just put on the power and let it bake. Put the old fire to the wire, as it were. But yeah, it's fine. So I'm going to put a battery in, and okay. You see the recess works really well. Beauty shot on my scope. My handy 564B. I've got two of them. They came from Columbia University's audio lab. They were parting that out. That was one of my many great plunders. Was the audio lab at Columbia Teachers University. But yeah, this is my old faithful, the 564. Okay, so I'm gonna look at this is the audio input right here. Get a good contact here. There you go. Yeah, it's a little bit of interference there. So it looks like radio. So I'm gonna, even though the switch isn't working, so I'm just gonna go right to the pin here. Oh, there we go. So there's the output of the effect, and that looks correct because that's the sweet effect. I'm gonna turn down the. Hang on here. Get the probe on there. Turn down that's the volume control. This is the saturation control right there. And turn down the input. Audio input here. Okay, here we go. Now that's not going to go totally flat. Okay, so that's close to, because there are rectifiers in there, diode rectifiers that actually create the effect. So when you're below the knee of the diodes, it's going to be linear like that. And then as you turn up the gain on the input, this is the audio input gain, it's going to begin to clip there, and you're beginning to see there. Here. Come on, get a good contact here. Get a good contact, come on. Got a dodgy switch in the probe. Come on, you can do it. I need new scope probes. These are like 20 years old. Oh, really? You're going to fail on me? Looks like my scope probe is... The 10x switch on my scope probe is not making contact. I'm going to switch my probes. Looks like this probe is... Yeah, I definitely need some new scope probes. Also, my cat, when Missy was alive, she used to love to chomp on my scope probes, so she might have bitten through that one. Alright, we're running again. Okay. So, changed out the probe. Alright, there. Alright, we got that again. Oh, okay. Alright, there's the output. Alright. Yeah, good probe. Makes all the difference. Okay. So here's the saturation, and if I turn down the attenuation there on the input, it'll go linear. As I turn up the input volume, you can see it starting to knee out there. That's the rectifier kicking in. Yep, and now I've got it up to full well, that's basically good input volume to minus 20 dB. Okay, and this is the tone control. So as the tone control goes to, it's basically a bandpass filter, and as it goes from low pass to high pass, that's the low pass end. It's going to cross over, and you're going to see the two knees. There you go. And now it's going high pass. That's the signature. That's what the Sweet looks like. That's the signature at 1 kilohertz. If I change the input frequency, yeah, you're going to see see there, I can get almost completely square wave at about 2K. And you can see how the wave shape changes with the frequency. That's one of the characteristics of the dynamic tone of the Sweet. And depending on where the tone control is set, again, change that frequency again, you'll see that it responds with different wave shapes as the frequency increases, going through that complex filter. Alright, but the effect is working fine. It doesn't need to be recapped. I don't see any noise in it. And the tonal response, it's exactly what I'd expect to see in the Sweet. So, yep, no worries about that. Yep. And volume, yep. So it looks like this is just a foot switch, which is an easy repair. Alright. Well, my philosophy is if it ain't broke, don't fix it. So I'm not going to replace the caps if they're still functioning. It's the kind of thing that if they started to fail, then yeah, I'd recap it, but I'm going to keep it original. And so this particular kind of foot switch, I only used this in the 90s. By the time the Sweet and other Frantone effects got into production in 2001, I had come up with a different kind of switching system. In the 90s, I was using switched outputs, so because they only made double pole foot switches back in those days, so you could make up an effect back in those days one of two ways. You could make it true bypass with no indicator. We're using both poles to switch the input and output of the audio, or you could have switched output with indicator light. So if you had an indicator light on a pedal of this era, one side of the switch would switch the indicator light and the other would switch the output of the effect. But basically the effect would always be on and the audio would always be going through the effect. You'd just be switching the output. But to have true bypass, you really need three poles. You need to have the input, the output, and the indicator all switched independently. And I was able to do that in the production run because I started using a signal relay. These low current tiny little PCB mount relays that were used for telecommunications switching. Putting those into the production units, I was able to make 9-volt battery-operated stomp boxes that were true bypass with indicator light. And as far as I know, I was the first to do that in battery-powered pedals to have true bypass with indicator light. It wasn't until they came out with those 3-pole double throw foot switches later on that everyone started using. And today everyone uses the 3-pole switches, including myself. So this is the benefit of not throwing anything out. This is my final stock of original switches from the 90s, the ones that I used in the last run of Peach Fuzzes, like in 98. And it's actually, this switch would have come from this very lot of switches. So these are exactly the same lot as the switch in the prototype. So I'm actually going to use one of these switches to replace that switch, so it's actually going to be period correct, the repair. So it'll be essentially all original. But that's the great thing about having a huge inventory of parts. You can just reach in the bin and grab another one, even if it's, you know, what, 19 years later, 18, 19 years later. So yeah. Feels right. Usually 9 out of 10 times, if a switch is going to be faulty, you can feel it when it's out of the box. And I do that by just taking the new switch and just cycling it really hard. And if there's a defect in the plunger, in the switchover teeter-totter mechanism, you'll feel it when you're first using the switch. And if it feels asymmetrical in any way, or if the click is asymmetrical, or you feel it grabbing on one side, chances are good that's going to fail within the first, few hundred cycles. But in this case, they do wear out too. So, after decades of being stomped on, they will. I mean, the parts in these switches, they're plastic generally. So you've got a little plastic teeter-totter in there, and so you have metal parts slamming against plastic parts, and plastic parts that are running inside of plastic rails, and they wear out. And sometimes if they're if the plastic gets brittle with age, you can just, the elastomers leach out of the plastics in the internal parts over years, decades, and then it just gets brittle, and then one day you stomp on it, it snaps, and not only does it snap like that, it also snaps internally, and you end up with a piece of the mechanism just breaking off, and it no longer snaps, which is probably what happened to this one. But yeah, replace it with the actual switch part, same lot, same vintage, from like '98. So yeah, all right, that'll be a proper repair. All right, so before I actually go and cut anything, I'm actually just going to make a diagram of the wiring, since this is a prototype. Make some notes about where the wires go before I go and desolder it. I make the notes, desolder it, and then just drop the new switch in. So, all right, so this is pretty much it. And again, this is the old '90s style switched output. So we've got, I guess this would be effect on, and that would be bypass. That would be the bypass effect, which, well, it's technically is bypass, but it's the effect is always on, so it's always taking down the input signal slightly with this type of design. But this was really the best we could do in the '90s if you can have an indicator light, but with very high impedance input, so you don't have to really worry about it. But if you had a lot of these types of pedals strung together, you'd have signal loss, which is why we ended up going to true bypass with indicator with the relay back, well, like following year. But here we have the output legs, the sides going to the ground. So this is switching ground from the indicator, and this one goes to the pot on the sustain. So it's actually grounding out the signal, so that when you're in bypass mode, well, in quotes bypass mode, because this is not a true bypass, but when you have it in the off mode, where the signal is going with the signal throughput, so you're actually grounding out the signal so that the effect isn't actually going to be functioning. You're grounding out the signal line in the effect when it's in the off position. And on the other side of the switch, or the other pole switch, you're switching signal. There's the output, and there's the input, so you're either switching output to input, and so you're basically playing through, or you're switching to the effect, which is coming off of the volume pot, the middle wiper of the volume pot, and then you're playing the effect. So effect, indicator light, or off, and signal going through. So I'm going to detach the wires, put in the new switch, solder it in place. Okay. Take out the old switch. Very same wrench I've been using to fasten every single nut on every single Frantone pedal since I started making them. In fact, I ground an angle on that because in the old days with the thicker cases I actually had to go on the inside and tighten from the inside because in the original Hepcats I was putting a ring nut on the outside, one of those knurled ring nuts which you couldn't get a tool on, and I put those on the outside so it looked really nice and fancy, and then I'd tighten it down from the inside. But in order to do that I had to angle the the end of the wrench so I could get in, at an angle and do that. But this is the wrench I've been using to put on every single foot switch on every single Frantone I've ever built. So it is one tool with a lot of usage. So I put a lock washer on that too. Something I don't really typically do. switch actually wasn't supposed to be turned like that. It was really supposed to look like that. It was kind of turned a little to the side, but that wasn't the way it should have been originally. I had it turned around because this wire was too short. That's why I had it turned. It's interesting. I'm just going to reroute the wire though. So I've got room to bring it over the top of the switch, so that's what I'm going to do. And this is Teflon wiring. I was using a lot of Teflon wiring in the hi-fi work I was doing back then, so I had an inventory of wire. And yep. That's what I'm going to do. Yeah, plenty of room. So I'm just going to reroute that so that the switch is in the correct position. Yep. Got these switches are really old. I'm going to have to put some extra flex on these contacts here. That's more like it. We got one more. Dropping resistor for the LED. Oh, the tremor's really getting to me here. Alright. Yeah, that essential tremor. Gotta love it. Alright, there it is. I rerouted that one wire, but that's fine. Got 6 really good connections in there. Nice and shiny. Just do a final test on that. Make sure that the switch isn't noisy. And yep, repair the label, and essentially the repair is done. Alright, so final step, repairing the label. Obviously the best thing to do would be to remove the hardware, and it'd be very easy to get some glue under there and just lay something flat on top of the pedal and flatten it out. That would be the obvious thing to do, except that this is a prototype and it was never intended to be taken apart. My concern is that in order to take the hardware out, I have to remove the circuit board, and my concern is that if I try and snap these number 6 screws out of those threaded standoffs, at least one of them, if not more or maybe all of them, will break away from the glue because they're glued down with that goop, and so it's going to end up with a big problem with disassembly. I'd probably break one of those standoffs off and have to reattach it, and I don't have like a similar compatible glue here at the moment. And the LED is held in one of those rubber grommets, and that might not come out in one piece, or if I take it out it might not reseat itself when I try to put it back in there. And plus I'd probably have to undo the wiring to get things out because things were tie wrapped here and everything. It would be like a complete rebuild if I had to take just to get the hardware out. So it makes more sense to try and get around that problem by leaving the hardware in. So typically I would not use a water-soluble glue, but I'm going to use just a regular white glue because it's a paper label, and also the residue of the adhesive is still on the paint. So that's a porous surface. So if I get some white glue under there, it's going to retack to that old porous surface, and I think it's going to actually grab if I do that, because that old adhesive, it's dried up, but it's still pretty firmly planted on the paint. I've actually gotten in there and scraped on it a little bit, and it's still stuck on there pretty good. So so it's a good porous rough surface for white glue to grab on. So I think it's probably my best bet. But to when I do this, I'm going to use a little trowel spatula like this. It's used for painting oil paints and such. But a trowel kind of spatula like this is what you would use to fix like a veneer or something like that. You put a little glue on the top, and then you can get it underneath, like so. The problem is that this glue is going to dry very quick. Right now it's January. It's about I think it's 6 degrees Fahrenheit outside, and the humidity in here is as close to zero as you can get in North America. So this glue is going to dry very quickly. So I knew that once I get the glue under there, I'm going to have to get it pushed down like right away, because it's going to start to dry pretty much as soon as I smear it thin. So I thought the thing to do would be to make a little guide, like a template, something that would apply pressure and be flat. So I cut a piece of, this is 1/2 inch foam core. Stuff is really great. It's dense and flat, and I took an old this is an old broken casting. This is a production case that got busted in shipping, but I used this just to draw out a template of the knob positions and such. This would be going this way, and I put a layer of tape on it again to protect from the glue, any excess glue coming out the side, attaching the paper foam core down to the to the paper label to get them not to stick. Put some tape on there, and I'm just going to take an X-Acto and just cut this out, and then that should go down. I'm going to remove the knobs, and that should fit around and apply the pressure around the outside, and so I can just quickly skim the glue under there, put the template down, put a weight on the top, and let it dry. So that seems to be the best bet, the best way to fix this. So yeah. Don't even have to take the knobs off. Doesn't look like. Just turn the knobs. Yep. Just gonna cut a little bit around the switch. Well, I'm gonna remove the switch hardware. I'm gonna leave the switch in, but I'm gonna take the nut off, and that'll work just fine. And then I can just put some weights on this, and that'll hold the label down. That looks like it'll work. Yep. There you go, template, and glue proof too. So, yep, very nice. Sweet. Oh, yes, sweet. There we go. Perfect. Perfect. Gonna take the piece that I took out, I'm going to tape that down so I can put the glue on that. Use that scrap. I'm going to put the glue on that so I can scrape off of that and it won't move around. Put something really heavy on there. Fortunately, I have something on my desk that's just about heavy enough to do the job. Alright, I knew that would come in handy for something. The Heath kit. I'm going to let that sit overnight, and yep, with any luck, maybe that'll be properly stuck down tomorrow. Clean up the overage with a Q-tip. Good thing with water-soluble glue because I had treated the top of the case with acrylic. I can just take some of the glue spillage off. The label is sealed, so it's probably going to take a little while to draw on the inside. So it's pretty much done, flattened, but I'm going to get the nut back on and it'll be fine. That's it for this one. Thanks for watching. Thanks too to all my patrons who have been hanging in there, hanging strong while I'm doing this moving stuff. You know, my video content has dropped quite a bit in this tearing down and moving stuff out thing that I'm doing. But thanks for hanging in there, patrons. You make all this possible. And if you like what I do, if you're new to the channel, if you like these videos, then consider becoming a patron. It's how we finance all this. It's all done through Patreon. If you want to become a patron, it's easy to do. You just follow the link in the description. Become a patron. Okay. That's it. I'm Fran. I'll see you around real soon. Bye!